A summer camp has 240 feet of float line with which to rope off 3 adjacent rectangular areas of a lake for swimming lessons, one for each of the 3 levels of swimming ability. A beach forms one side of the swimming areas. Suppose that the width of each area is 8 yards or X yards. So let's begin with a diagram. And so I have a rectangular area, and then I'm going to partition this, and I want to create 3 different adjacent areas. Okay, so I'm going to do a line here that gives me one area here, another line, there's 2 areas, and then I have this other line here that's, let me go ahead and make this more equidistant. So basically I just have to make 2 lines inside of this, and then I'm going to get my 3 areas. Now each of these is X yards. And you have to label those because this is rope here. So we're actually using rope for these partitions. And then we have a length of rope here on this other side. Now this one side here is the beach, so I don't have to have any rope there. So I want to express the total area of the 3 swimming areas as a function of X. So the total area is a big rectangle. So area of the big rectangle, well, I know that the one dimension is X, that's my width, and I need to know my length. So my total length over here is going to take the total feet that I have of rope, and I have to subtract off the rope I've already used, and I've used 1, 2, 3, 4 sections of rope for X. So 240 minus 4X is going to be the length. So the area is X times 240 minus X. So A of X equals 240X minus X squared is the area of the entire swimming section. Now the domain of the function, we need to really just remember that area must be positive. It can't be 0. So if I take this area that I got here with the 2 different factors, X and 240 minus X, then I want to make sure that each factor is greater than 0. So I get X must be greater than 0. So that's already solved. And then 240 minus X must be greater than 0. So we need to solve this one. So if I subtract 240, I get negative X is greater than negative 240. Divide both sides by -1, and when you divide by negative, you have to flip the inequality. So I get X is greater than 0 and X is less than 240. And that's going to be the domain restrictions. My rope, my length must be from 0, greater than 0, but it can't be greater than 240. And so you can put that together like 0, comma 0 is less than X is less than 240. Now the graph of the area, it's a parabola facing down, so we have a maximum point here. And this is graphing the area of the rectangle. So we have all these different ways to get that same area of 200, or the same area where we have 240 feet of float line to rope off. But the maximum is going to occur here at this point, the vertex. Now the ordered pair is 30, 3600. So if we identify what these 2 numbers are, the first number is our X, and remember X was our length in yards. That was the width. So then this other value would be the Y coordinate, but for our area formula it's A of X. So this is our area in square yards. So our maximized area is 3,600 square yards if we choose a width of 30 yards. So then what are the dimensions going to be? Well, if you just take 3,600 divided by 30, you get 120 yards for the length. So the dimensions to maximize the area would be 120 by 30. So that means if we go back to our diagram, each of these partitions here would be 30 yards, which should leave us with 120 yards of rope for that horizontal length. And if you add up 30, 30, 30, and 30, you get 120, and 120 plus 120 does equal 240 feet of float line.